Hi dear students, today let's discuss about the domestic electric circuit and the question answers related to this topic as well as the exercise question answers. Okay, let's start. Okay, in our homes we receive supply of electric power through a main supply either supported through overhead electric poles or by underground cables. One of the wires in the supply, usually with red insulation cover, is called live wire. Another wire with the black insulation is called neutral wire, or it is also called as negative. So in our country, the potential difference between the two is 220 volt. We get 220 volt, the potential difference of voltage. Okay, at the meter board in the house, these wires pass into an electricity meter through a main fuse. Through the main switch, they are connected to the line wires in the house, and these wires supply electricity to separate circuits within the house. Often, these two separate circuits are used. One of 5 ampere current rating for appliances with the high for bulb, fan, etc. Then the 15 current ampere for a geyser, air cooler, refrigerator, etc. There is one more wire, that is earth wire, which has insulation of green color. It is usually connected to a metal plate deep in the earth near the house. And this is used as safety measures, especially for those appliances that have metallic body, for example electric press, toaster, table fan, refrigerator, etc. And the metallic body is connected to the earth wire, which provides low resistance conducting path for the current. Thus it ensures that any leakage of current to the metallic body of the appliances. Dear students, do you know what type of electricity is supplied to our home? It is alternating current. And how much voltage is supplied for each home? It is 220 volt, and the frequency of current supplied is 50 hertz. Okay, so what is live wire? The wire which is at 220 volt potential is called a live wire. Okay, it is also called as a positive wire, and the neutral wire is the wire which is at 0 volt potential, and it is also called as a negative wire. And then earth wire, which is connected to a plate deep in the earth near the house. So as you can see in this picture, the earth wire is connected a deep plate near the house, and so the earth wire which has insulation of green color, okay, it is in a green color, and it is it protects the all appliances. Okay, now observe this picture here. In each separate circuit, different appliances are connected across the live wire and neutral wire. Okay, observe this. Then each appliances has a separate switch to on off the flow of current through it. And one more thing here, all these appliances are connected in a parallel, right? Parallel to each other. Why they are connected parallel to each other? Because when they are connected in parallel, they get the same voltage. Okay, in order that each appliance has equal potential difference when they are connected parallel to each other. For that purpose, all the appliances are connected in a parallel. Okay, yes. Okay, there is a one more component, that is electric fuse, and this fuse consists piece of wire made of metal or an alloy of appropriate melting point. Example, aluminium, copper, iron, lead. So it is inserted in the circuit. Okay, why it is used in the circuit? We already studied the principle and working of fuse in the electricity chapter, right? So it works based on the Joule's law of heating. Okay, so what does it indicate? That is, when Joule's heating that takes place in the fuse, it melts and it breaks the circuit. Okay, and mainly a fuse in a circuit, it prevents damage to the appliances and the circuit due to overloading. So how it prevents the damage to the appliances? When a current that is larger current that than the specified value flows through the circuit, then the temperature of the fuse wire increases and it melts the fuse wire and finally it breaks the circuit. Okay, this is the working of a electric fuse. And also it prevents the circuit due to the overloading. So what is this overloading? Overloading occurs when the insulation of wire is damaged or there is a fault in the appliances. Okay, and also it can occurs due to an accidental hike in the supply voltage, and also sometimes due to the excess current this overloading may occurs. Okay, then what is this short circuit? You might have heard about this, right? So when it occurs, this short circuit, when the live wire and the neutral wire come in direct contact, then the short circuit happens. Okay, now what are the precautions we can take to avoid this overloading of domestic electric circuit? So one is, too many appliances should not be connected to a single socket. So the first one, name two safety measures commonly used in electric circuit and appliances. So in electric circuit, earthing, it is a safety measure, and in appliances we use electric fuse. Next, second question, an electric oven of 2 kilowatt power rating is operated in a domestic electric circuit that has a current rating of 5 ampere. So what result do you expect? Explain. So usually electric oven takes lot of current, right, to work, but current rating is 5 ampere. Okay, let's discuss the answer. The electric oven draws the current given by, so we know that the current I is equal to power over voltage supplied. Okay, voltage supplied is constant, right? So power is 2 kilowatt, then over 220 volts. So when we simplify this, we get a 9.09 ampere. So what would happens? This is access, right? Access current. Thus, the electric oven draws current much more than the current rating 5 ampere. So that is, the circuit is overloaded due to excessive current. The fuse wire will blow and the circuit will break. The next one, what precautions should be taken to avoid overloading of domestic electric circuits? To avoid, answer is that to avoid the overloading of domestic electric circuits, the following precautions should be taken. That is, this already we discussed. Too many appliances should not be connected to a single socket. Too many appliances should not be used at the same time. And faulty appliances should not be connected in circuit. The last one is fuse should be connected in the circuit. Okay, now this is the exercise question answers. Okay, so state whether the following statements are true or false. First one, an electric motor converts mechanical energy into electrical energy. Motor converts electrical energy into mechanical energy, right? So this statement is wrong. Then the second one, an electric generator works on the principle of electromagnetic induction. So what is the answer? It's right. True it is. Then the third one, the field at the center of long circular coil carrying current will be parallel and straight line. Okay, it is true. The field at the center of long circular coil, that is circular coil carrying current, will be parallel to the straight line. Then the last one, the wire with the green insulation is usually the live wire of a electric supply. That is false. Green insulation is a earth wire, right? Okay. And the next one, at the time of short circuit, the current in the circuit, what happens during the short circuit? Increases heavily. Okay, next, the seventh one, list two methods of producing magnetic fields. Here 3 points are given. Okay, first one, magnetic fields can be produced by placing permanent bar magnet or horseshoe U-shape magnet at the place where magnetic field is required. One is what? By using bar magnet or U-shape magnet. Then the second one is a magnetic field is produced around current carrying straight conductor or a current carrying circular coil. In this case also we get magnetic field by using a straight conductor, current carrying straight conductor. Then the last one is by using a solenoid. Okay, so from all these we get a magnetic method, we get magnetic fields. Next one, how does a solenoid behave like a magnet? Can you determine the north and south pole of current carrying solenoid with the help of bar magnet? Explain. So when a current is passed through a solenoid coil, what is solenoid? It is a cylindrical shape pipe for which the wire is wounded. So magnetic field produced due to each turn of solenoid coil is in the same direction. Okay, when a current is passed through a coil solenoid, then the magnetic field is produced. Why? Because due to each turn of solenoid is in the same direction. As a result, the resultant magnetic field become very strong and uniform. So the field lines inside the solenoid are in the form of parallel straight lines along the axis of solenoid. Thus, the solenoid behave like a bar magnet. One end of the solenoid behaves as a north pole and the other end behaves as a south pole. So how can we determine the poles of the solenoid? Yes, the end of the current carrying solenoid which attracts north pole but repels south pole of a bar magnet, then it is behaving like a south magnetic pole. Always like poles repel each other, right? Unlike poles attract each other. So here when we bring a north pole of bar magnet to one end of the solenoid, if it attracts then it is a south pole, and if it repels then it is a north pole. Similarly, the other end which attracts south pole of bar magnet but repel the north pole, then it behaving like a north magnetic pole. So it is because like poles repel but unlike poles attract each other. The last one, when is the force experienced by current carrying conductor placed in magnetic field largest? So when the magnetic field becomes largest, yes, when the conductor carries current in the direction perpendicular to the direction of the magnetic field, then the force experienced by the conductor is the largest. Okay, copy these question answers in your notes and learn those question answers. Thank you.